After all those oohs and ahs, I bet you're all a little bit thirsty, aren't you?
Yeah.
Some water? Well, actually it's empty, isn't it? Is it empty?
No.
There's air in there, exactly. There's some air in here. And air actually has some mass, and it takes up some space. It's a gas like all gases. It does take up space. If I add some more air to this, it just pops right back out to the way it should be, right? Well, gases are all different, and if you look above my head here, you'll see that I've got some gases in those balloons. What gas do you put in a balloon to make it float? Helium. And why does helium make a balloon float?
It's lighter than air.
It's lighter than air. But you know what? There's another gas lighter than air, and it's called hydrogen. Well, how do I know whether I've got helium or hydrogen in these balloons? I've got to find a difference between the two and test it. And I know a very important difference between helium and hydrogen. Don't tell anyone, but helium is boring. It's the most boring gas there is. It doesn't do anything. It won't react with other chemicals. It won't react with the heat from a flame. It won't even react with another helium atom to form a molecule. It's downright boring. In chemistry, we call that an inert gas. I think that's just another word for boring. So boring that if I were to take this and put it up to a helium balloon, watch what happens. You thought it was going to pop. Big explosion, didn't you? It doesn't. Helium's boring, remember? Hydrogen, though, is not a boring gas. It's a very reactive gas. Reacts with oxygen to form water, H2O. Reacts with carbon and oxygen to form sugars. And watch what happens when we do the flame test on it. Don't block your ears. You ready? Certainly not boring, is it? Absolutely not. Well, those are just two gases, helium and hydrogen. I'd like to talk about some other gases, and I'd like everyone to take a deep breath. Hold it, and exhale. What did you breathe in?
Oxygen.
And what did you breathe out?
Carbon dioxide.
Carbon dioxide, exactly. Actually, when you breathe in air. Okay? And only 21% of the air is oxygen. Most of it, 78% of it, is nitrogen. Very good, nitrogen. Okay? Well, I don't want the nitrogen, I want the oxygen. Well, how do I get oxygen? I'm going to make it. I need a volunteer to help me make some oxygen here. Ooh. Right over here. Come on up. What's your name?
Leander.
Okay. What I need you to do here, first we have to make them look like a scientist. Okay. So we're going to put this on you. All right. Now we really, come on, we've got to roll these sleeves up. Okay. Really make you look like a scientist here. Okay. And I think we better cover his eyes, so we're going to put these on you. Okay. And we want to make sure we protect your hands, so we're going to put these on you. Okay. All right. Does he look like a scientist? Okay. Actually, what we've done is made sure that he stayed safe from anything that we're going to do. I'm going to put my glasses on too, and he's got a very important job. He is the holder of the bag. Ooh. Okay. First of all, we're going to make some oxygen. And we're going to do that with a chemical that's very hard to get. You have to go to the grocery store and buy some yeast. The same thing that you use to make bread, we're just going to use some yeast for this. There you go. All right. Now the next thing we're going to add is hydrogen peroxide. The same thing you put on a cut to make sure you don't get any infection. So we're going to add some of that into there. So now we're going to close this up very quickly. Okay. And I'd like you to shake this up. Okay. All right, we're just going to let that sit there for a second. Now we're going to take the next bag. This time we're going to make carbon dioxide. So once again, our holder of the bag is going to do his job there. We're going to pour in some baking soda. another real tough chemical to get a hold of. Okay. And we're going to add some vinegar. Okay. We're going to close this one. All right, now what I'd like you to do is take your gloves off. Okay, and we can put those here for a second. I'd like you to feel this bag. Is it hot or cold?
Cold.
Cold. Now feel this one.
It's warm.
It's warm, okay? And that's because there's a difference in these two reactions. This one is an exothermic reaction, which means it's going to be giving off heat, and that's why it feels warm. This one here is an endothermic reaction, which means it's taking in heat, so it's taking the heat away from your hand, so it feels cool. Okay? But there's another difference between these gases, and we're going to take a look at that difference right now. I'd like you to hold that. Okay? And once again, we're going to try to see what happens. You're getting real nervous here, aren't you? Now remember, to burn something, you need three things. Does anyone know the three things you need to burn something? Yes.
Oxygen, fuel, and heat.
Heat, oxygen, and fuel. Well, there's 21% oxygen in the air. We've got the heat now because we used the lighter. And we've got the fuel, which is the stick. If you open that up, remember, we made carbon dioxide. And carbon dioxide doesn't have oxygen. Okay? And it's CO2, it's what you exhale, so it puts out the flame. Alright? Now, we'll grab another stick here. And hold this one. Don't open it up yet. Alright, I'm going to blow this out. Now there's not enough oxygen to light this, but if you open that up, hold it up high. There's plenty of oxygen in the bag to actually light up the stick. Alright. Put these aside for a second. No, don't go away. If you notice, we've got one more bag here, so I need you to put the gloves back on. Move these aside. So I need this one. This one is, we're going to use a chemical that you really can't find in the grocery store. First of all, we're going to start off with vinegar. That one you can find in the grocery store. But the next thing we're going to add is magnesium metal. Okay? Just a metal. And a little bit here. That may be too much. There we go. Okay, this one's an exothermic reaction. It's giving off heat. I'm going to have you keep your gloves on for this one, which probably worries him. Okay. Very much, huh? Okay. Alright, now. I need to find the ends of the bag here. Okay, can you... Okay. When I say go, open it up. Did you all see that? Worried you, didn't it? Now you know why we put that. Now we know why you put the glasses on the lab coat, huh? All right, let's give them a hand. You can go back to your seat. You can leave the glasses and the gloves up here. Scared you, didn't it? All right, you can keep the coat on for now. All right. Really keep the look of the scientist there. Now what I'd like to do is move on to some bubbles, because Charles did mention that we were going to be working with some bubbles today. So I've got some bubble solution here. By the way, bubble solution is real easy to make. All you do is you take water and corn syrup, and a little bit of corn syrup that makes the bubbles stronger, and then you add some Dawn dishwashing detergent. And you can make bubbles like that. Okay. Or you can take a propane tank Well, they don't want to make bubbles today. Let's stir that around a bit. It's been sitting there a while. Okay. We're going to put a match to the ones that blew up and just pop the bubbles. Then we're going to put a match to this one. Because it's propane, it's a different gas, reacts differently. It just sort of burns away.